good morning to each one of you, dear students. Hope so you are fine and taking due care of yourself. So welcome to the world of chemistry. Dear students, welcome to digital classes. This is your chemistry period, and as we are doing unit 4, chemical bonding and molecular structure, today we are going to do in this chapter a very important topic, not only in chemistry, in this chapter also, that is VSEPR theory, which is also known as valence shell electron pair repulsion theory, which is very important. This theory is helping us to know about the basic structure of molecules. Okay, so before going to start, as usual, let's start with the positive mindset, as today's thought is success doesn't just find you, you have to go out and get it. So dear students, let me explain this. To witness success, you have to give time as well as dedication. This is the first mantra. No matter how severe your goal is, nothing can replace hard work. If you think that success will come to you without any effort, my dear students, you are wrong. There is no such thing that you can attain without giving effort. So it is the time when you should throw away your ideal life and start working on it. The most important thing that you have to do is to craft a plan. Without a proper plan, you can't witness the success of your desire. And also, to achieve your goal, you must take the risk. Staying away from the danger and challenges will do nothing good to you. Also, if you take risk, you will learn some of the essential lessons in life. So dear students, as I told, success is not something that we can achieve overnight. Success doesn't just find you. You have to go out and you have to get the success. Okay, as nowadays you all are at your home and you are studying with the help of digital classes, we are trying our best to teach you, we are trying our best to give you. So it is up to you now. You need to leave your comfortable zone, you need to take these classes seriously, and you need to put some extra effort to get success in future. So hope so you like this thought and you will implement this thought in your life. There is only a single motive to start my lecture with the help of this thought. That is, I just want to motivate you, encourage you, so that you are going to grow day by day in your life and you will become a very good student in future. Okay, so let's recapitulate whatever we did. You know very well, we have started this chapter and we did in the previous video what is the meaning of chemical bonding. So chemical bonding is what? So it is the attractive force between two element and atom which form a molecule. And second, if you know now what is chemical bond, if it is attractive force, then you should have different question. Why element combine and form molecule? Okay, let me explain this slide specially because it is very important slide which we are going to do today. This will connect with previous topics. Okay, as I told you one day, a good learner, one of the good quality of good learner is to inculcate WH family. So WH family is, you should know, if you want to get knowledge, if you want to become very good intelligent student, so you should have this quality in you. You should keep on thinking what, why, how, where, when. So that's why I made this slide. So when you come to know once what is chemical bonding, then your second question can raise in your mind, that is why elements combine and form molecule. Why those atom will combine? Why those atom will make chemical bond? Very simple. To get satisfaction, to get stable, because except noble gas elements, none of the elements are stable. They are not having noble gas configuration. To get noble gas configuration, these elements are combining. So what do you mean by octet rule? Yes, to satisfy octet rule, to get octet, elements are combining. So what is octet rule? This rule states that the element or atom should have 8 electron in their outermost shell. If it is more than 8, it will donate electron. If it has less than 8, it will gain electron. Next is, what are different types of chemical bonding? Yes, generally there are 5 different types of chemical bonding: ionic bond, covalent bond, coordinate bond, hydrogen bond, and van der Waals force. But basically in this chapter we are studying most in detail, that is ionic bond and covalent bond. And what is the basic difference between ionic and covalent bond? Ionic bond is it is the bond between metal and non-metal. It is the bond between cation and anion. It is the bond because of ion. Whereas in covalent bond, the covalent bond is basically between the non-metals with non-metal, and it is why due to sharing, mutual sharing of electron. And covalent bond and its characteristics we did. Then bond parameter we did, which help us to detect the bond length. Bond length is telling the size of molecule. Bond angle determine the shape of molecule. Bond enthalpy is states that strength, and bond order is telling the number of bond. So after this, about polarity. Polarity is what? Polarity is to which side. Basically, ionic bond is forming polar and non-ionic bond covalent is showing. So I want to show you this picture. With the help of this picture, I think you can relate that what is two type of polar. So polar, you can see here, it is ionic because chlorine is pulling the electron from hydrogen. So it means that directional it is. Its pole is toward chlorine side. Whereas non-polar, both it is covalent, both have equal amount of electron. So this is non-directional, that's why non-polar. Okay, so hope so you understood the polarity and non-polarity. So now next question is how to predict the geometry. Now if we know about the attractive force, we know about which side electron is moving, we know that how many types of bonding is there. So now next question is how to predict the geometry. This is very important. What is geometry? Geometry represents shape, size, angle, bond length, everything. So before going to start the geometry, or if I'll say how we can determine geometry, so there is one very important theory, that is valence shell electron pair repulsion theory, with the help of which we can determine the geometry. So let's start the introduction, then we will going to start about this theory. So basically VSEPR theory was suggested by Sidgwick and Powell in 1940. Again Sidgwick and Powell in 1940. It was developed by Gillespie and Naylor in 1957. It means that it is modified by. Okay, basically this theory was suggestion only given by these two scientists and developed by Gillespie and Naylor. Based on that, a polyatomic molecule, more than one element. Suppose hydrogen is one. When hydrogen will react with hydrogen, it will form H2. But when this H2 will react with O, it will form H2O. So H2O is polyatomic because here are three atoms are there is collaboration of three atoms that make this molecule. So polyatomic is more than two element. Okay, so in which the direction of bond in the center atom depend on the total number of bonding and non-bonding electron. Once again I want to repeat, bonding and non-bonding electron. So two type of electrons are coming. One is bonding, second is non-bonding. So basically bonding electrons are forming bond pair, non-bonding electron forming lone pair. Okay, so again keep these two words in your mind. See carefully, bond pair I said, bond pair and lone pair. So again and again you will listen these words. So today basically we are going to start. This is the basic characteristics of VSEPR theory, bond pair and lone pair. So let's understand what is bond pair and what is lone pair. So we are doing balance. Balance means the number of electron present in outermost shell. Okay, the valence electron. How many electrons are balanced in shell, and the pair of that electron which repel, which is giving the geometry with the repulsion theory. Repulsion means that is moving away. Okay, so because of that, the shape of molecule is determined by repulsion between all the electron present in valence shell. Electron pair in present in the valence shell. Electron pair in the valence shell of the central atom repel each other and align themselves to minimize this repulsion. Lone pair electron takes up more space around the central atom than bond pair. So this you are going to understand in next slide. Lone pair attract to one nucleus, but bond pair shared by two nucleus. Okay, basically lone pair is attracted by one nucleus, and bond pair is sharing of two nuclei. The minimum repulsion of the state of minimum energy and maximum stabilization of the molecule. So let's understand the basic application of VSEPR. Valence shell electron pair repulsion theory is basically where it is applying. It is applying to predict the geometry of individual molecule from the number of electron pairs surrounding their central metal. Okay, so it is used to determine the geometry of shape. Basically, what is the application of VSEPR theory? It is used to determine the geometry of shape. I mean the particular geometry is of which shape. So VSEPR theory, again, V for valence, S for shell, E for electron, P for pair, R for repulsion. This is a rule. These are the rules of VSEPR theory. Very important. We need to see. Definite shape of any covalent molecule depend on the number of pair of electron. Number of pair. How many number of pair of electron are If suppose two pair of electron is taking part in reaction, I'm taking example of beryllium chloride. So you can see here 2, it means that 2 bond is there. So B is in the center, chlorine and chlorine is in both side. So how many bond is there? 1, 2 bond. So this 2 represent 1 bond is this side, 1 bond is this side. So in this way, this is first rule of valence shell electron pair theory, that we can determine the number of bond with the help of formula. Second, covalent bond are formed due to the sharing of electron, and the covalent bond arrange themselves around the central atom. Next, the electron pair repel one another and arrange themselves as far apart each other as possible. An electron pair may be involved in forming the, so those electron which is sharing, that is called bond pair, which is not sharing, that is called lone pair. Okay, so repulsion between electron pair on outermost shell and central atom in molecule is in the order, mean lone pair have more repulsion than lone pair bond pair than bond pair. So let's understand in detail. As we have said, valence shell electron pair theory. So let's understand first how, before going to study about number of bond, we should know how to make the bond. Okay, so before this is whole valence pair electron repulsion theory is based upon electrons, transference of electron, a contribution of electron to make a bond. So let's understand before that the electron dot structure. So dear students, as you can see here, this is the example of carbon atom. So in carbon atom there are total 6 electron, in which 2 is in K and 4 is in L. So these are the 2 in K and these are the 4 in L. Okay, so once you will understand these 6, 2 and 4, so these 2 and 4, it means that 2 is in K shell. So how many electron are there in outermost shell? There are 4 electron in outermost shell. So what does the electron dot? These 4 electron can be drawn in the dot form, that is called electron dot structure. Hope you understand. So what is valency now? If you are talking about valence shell electron pair theory, so first we need to understand about valence shell electron pair. What does mean valence shell electron pair? So valence electron refer to the electron on the outermost electron. Okay, from here also, suppose if carbon is having 4 electron, it means that the valency of carbon is 4. Similar way, there are the only electron involved in the chemical reaction. These 4 electron will only involve in the carbon reaction. Atom will most stable if they have a full outer energy level. Atom will be only, now you know why atoms are combining, because they want to become stable. And how atom will become stable? When atom will become stable only when they will have full outer energy shell of in their outermost electron, in their outermost shell there should be full electron. It should be fully. Okay, suppose some atom which lose electron, we will take example of sodium here. 11 electron, 11 proton are there, 2 electron in K shell, 8 electron in L shell, and out of 8 1 electron is there in outermost shell. So because of that 1 electron, it is not fully filled. So it means that if it is not fully filled, it is not stable. So how it will become stable? It will become stable by giving this electron to someone. Okay, so review of chemical bond. Valence electron is outermost electron. S and P electron for main group element. It is responsible for chemical property of atom. These are participated in chemical reaction. And here the diagram of sodium has given in the form of shell. So electron configuration we studied in second chapter, in which 11 electron has distributed, 2 in 1s, 2 in 2s, 6 in P. So 2 plus 2 plus 6, it become 10. One left, that one will be in 3s. So rest all electron are fully filled, you can say paired. Only this last one is not paired. It means that only last shell will participate in making bond. Okay, so what is the valency of sodium in this way? 1 is the valency of sodium. It means that 1 bond sodium can make. So in this way we can find out how many electrons are there in valence shell. So it means that much electron it can share and it can become. Okay, so now understand the main difference between bond pair and lone pair. Bond pair and lone pair, electron are distributed as shared, or bond pair are shared electron are bond pair and unshared electron are lone pair. Let's understand with the help of hydrogen chloride. So you know very well, there are 1 electron in hydrogen and there are 7 electron in chlorine. So these 3 side it is paired electron only one side there is no pair. So electron somewhere, chlorine will take somewhere 1 electron from hydrogen and become pair. So which side it is making pair, that is called bond pair, and which side it is not taking care, that is taking part, that is unshared electron. So these 6 are unshared electron, that is called lone pair, and this one is shared, that is called bond pair. This is called Lewis electron dot structure. Okay, similar way we will discuss the main difference between bond pair is the pair of electrons that are in the bond, whereas lone pair is the pair of electrons that are in the bond. Always in bond. This is not in bond but can form bond by donating the lone pair. The two electrons belonging to two atoms, the two electrons belonging to same atom. Here created due to sharing of electron, here created due to absence of empty orbital. Hope so you understood, and write down the difference, learn the difference in your notebook, from your notebook also. Okay, so next is, let's understand simply how bond pair and lone pair can draw. We here one example has taken, that is of ammonia. If we will make the number of electron in nitrogen, so you know there are 7 which can be make 2 and 5. 7 total electron, so distribution is 2 and 5. Whereas hydrogen is 1, so it means that 1 is there. So now see, here nitrogen want 3 electron to make 8, but hydrogen have only 1 electron, so this will not satisfy. So it means that we need this kind of 3 hydrogen now, so that each hydrogen will give 1 electron, and 1 plus 1 plus 1, 3 electron total will make nitrogen 8. Okay, so same thing has happened here in this show in this shape. You can see here now, nitrogen have 5 electron in outermost shell and 3 electron nitrogen bond to 3 electron nitrogen bond to make octet. So each hydrogen is giving 1 electron to nitrogen. That's why these are making bond. So these all electron which is nitrogen has taken from hydrogen is known as bond pair. So it means that these are called bond pair, but which is already nitrogen have but not shared with anyone, that is called lone pair. So how many lone pair is there in nitrogen? There is one lone pair, in ammonia there is one lone pair. And how many bond pair is there? There are 3 bond pair. 1, 2, 3 bond pair, but this is one lone pair. Okay, and here I want to tell you one more thing, dear students. Let me make the same diagram in my own way. There are like this way nitrogen, but nitrogen bond one more electron, so nitrogen is taking one electron from hydrogen. This is this hydrogen, this is this hydrogen. So because of that this become bond. Okay, so this is becoming bond, 1 bond, 2 bond, 3 bond, but this is lone pair. So like this way we can show lone pair. Basically, if I make structure of nitrogen, this is hydrogen, this is hydrogen, this is hydrogen, because it is making bond, but which side it is not making bond, that will be made by like this way. So this is the representation of lone pair. Okay, so hope so you understood. Next we will understand, that is the bonding of lone pair. Bonding pair electron shared by atom. Lone pair electron doesn't shared by electron, it is their own electron, pair of electron. Okay, so let's understand with the help of hydrogen. Water, so in water case oxygen have 6 electrons, so red color electron are oxygen, 1, 2. So it means the 2 pair of lone pair and 2 pair of bond pair with hydrogen. So how many lone pair, how many bond pair is in water? 2 lone pair and 2 bond pair, and shape is bent shape. Draw the dot electron structure that we drawn. Oxygen has 4 pair of electron, 2 of which is lone pair. These are tetrahedral arrangement, and the bond angle is 104 degree because of the repulsion of lone pair. The shape isn't or described. Okay, what is the repulsion now? As we are discussing the repulsion, so when any molecule have lone pair, the lone pair will repel the shape. Otherwise oxygen water shape can be like this way. But why it is not linear? Reason, here is one lone pair, that lone pair is repelling this hydrogen and toward this side. Here is one more lone pair that is repelling this hydrogen toward this side. Because of that the hydrogen have this shape, this type of shape rather than linear shape. Okay, so these are some of the more shape. If we will take about example of methane, there is no lone pair, 0 lone pair, so all 4 hydrogen made bond pair. Whereas this is one tetrahedral, this is second type of tetrahedral where 1 lone pair is there, 3 bond pair is there in ammonia, and this is water, 2 lone pair and 2 bond pair. Okay, so basically how many direction is there? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you can see we have 3 different example with same type of direction. Okay, so this is all about lone pair bond pair information. Now the last is we will discuss this bond pair lone pair with the help of HCl. So you can see here, dear students, hydrogen can give 1 electron, chlorine have 7 electron, but chlorine want 8, so chlorine will take 1 electron from hydrogen and form octet. The chlorine form octet by 3 lone pair. These are 3 lone pair, you can say, but 1 bond pair. An electron pair is either bonding pair or shear pair and the lone pair, which is not shear pair. Okay, so valence shell electron we studied. Valence shell electron we know now. It is the number of electron that is left in valence. So now we will study about repulsion. What is repulsion? It is a general, as I said, more and more lone pairs. Suppose in methane there was 0 lone pair, as we studied in previous. In NH3 there were 1 lone pair, and in case of H2 there are 2 lone pair. It means that this have more repulsion than this molecule than this. Okay, more the lone pair, more will be repulsion. So that's why lone pair is having highest repulsion, then lone pair bond pair, and then bond pair have least repulsion. So electron in bond pair are held by attractive force, that 2 nuclei in the 2 atom. These electrons have less spatial distribution. These lone pair which is associated with only one repulsion, that is called a repulsion force of lone pair. Okay, and if we will take about bond, so triple bond have more repulsion than double bond than single bond. Okay, so conclusion is that VSEPR theory is used to predict the geometry. Number 1, it helps us to predict the geometry. Geometry of molecule depend on number of bond pair and lone pair, that also we studied. Number of bond pair lone pair is depending upon number of valence electron, that also we studied. And the repulsion strength we said lone pair is greater repulsion than lone pair bond pair, and then bond pair. Okay, so dear students, this is all about for today. So before going to end, you just have to see these questions and give the answer of these questions. Pause the video and just give the answer of these questions in my WhatsApp. Okay, so this is all about for today. Hope so you enjoyed this video and you understood. So dear students, once again in the last, as usual, when I am going to end the meeting, I am going to end the video with this appeal that always stay yourself safe, stay home, take care of your family, don't be corona carrier, be corona warrior. Thank you. Thanks a lot. Have a nice day.